everyone. Welcome to the AnexiPod, the official podcast for Anexinet. This is episode 12 for March 1st, 2017. I'm your host, Ned Bellavance, Enterprise Architect for Infrastructure Solutions at Anexinet. Here on the AnexiPod, we talk technology for the enterprise, covering infrastructure, app dev, analytics, and anything else that is shiny. On this episode, we will be boarding the airship SS Anexinet for a journey into the cloud. Helping me navigate the deceptively treacherous, fluffy cumulus clouds of possibility is Anexinet's very own cloud architect, Bert Zahniser. Welcome to the show, Bert.
Thank you, Ned. Great to be here.
Right. So thanks for being on the show today, Bert. Can you give the listeners a little background on how you got into IT and what you do for us here at Anexinet?
Sure can. So I started 25 years ago with a small company called Sun Microsystems, which grew very quickly and had quite a nice run in the 90s until they got bought by Oracle. I spent quite a few years there. Then I went off and started my own business doing consulting services around architecture, systems architecture, high availability, disaster recovery, and found myself in the early to mid 2000s doing a lot of consulting work and came across a small educational services company that was just starting to deploy their infrastructure and had a need for high availability and disaster recovery. And I had heard about this cloud thing out there, and I thought, wow, this is a small company. They don't really have the expenses to sustain building out a full HA/DR environment. What can we do in the cloud? And I fell in love with the cloud in 2010 when I started deploying stuff into the cloud. Was able to check that box for high availability and not have to worry about managing that underlying infrastructure. And from there, just saw the potential for the cloud and have been doing cloud stuff ever since.
Right. I think disaster recovery and HA especially seem to be an easy segue for companies to get into the cloud a little bit without having to re-architect a lot of stuff.
Definitely.
So we like to say around here that cloud adoption is not a destination, but rather it's a journey. How would you describe the various stages of that cloud journey?
Well, I can definitely identify with the fact that it is a journey. Most businesses I go into, they're just getting started in the cloud. There's a lot of fear around the cloud. A lot of traditional infrastructure people feel that the cloud is going to outsource their job.
Right. Oh my God, where did my job go?
Yes.
It's in the cloud now. I won't have anything to do.
So a lot of what I do initially is around education, helping people understand that the cloud's not replacing their job, but it should be making their job easier. And the steps to go through that journey, typically it's that education, it's some small use cases of success in the cloud, of how we deploy stuff, how we automate things and orchestrate stuff, and how I can show companies how they can scale their infrastructure with the same resources they have, and somebody needs to manage it, so their job's not in jeopardy.
Right. It's just hopefully taking the parts of their job that suck and shifting those over to the cloud and letting them get to do more fun and interesting projects.
Exactly. How many of our RT folks spend 50% of their time doing the same operational duties every single day? So
right.
If we could take that away from them and drop that down to 10% of their job, look at all the time that frees up to learn some new fun stuff. The reason why most of us got into IT.
Right. Exactly. So before you leave for a cloud journey, it's probably best to do a bit of planning. In this analogy, what sort of preparation should companies be doing before setting sail?
Well, in the ideal environment, before you would set sail, you do some planning and you look at what are your needs. So in a traditional data center, you know that you have to do some monitoring of your infrastructure. You need to know about uptime. You need to know about disk utilization, CPU utilization. You need to do security monitoring. All those things are in place in most people's data centers, but they're not necessarily there in the cloud unless you build them. So planning for how you're going to meet those business requirements in a safe and secure manner by providing that infrastructure monitoring, the alerting, the security monitoring, security alerting. What do you do if you have a security alert or a breach in the cloud? How do you respond to that? Incident response. So planning and understanding all those things up front are important to be successful in that journey.
Sounds good to me. And I know some companies have some business units that might go a little rogue. Like our boss likes to say, all it takes to start in the cloud is a credit card. and most business units have one of those. So a lot of the time, the main IT department is coming a little late to the cloud conversation. What can the internal central IT do to try to bring those business units back into the fold?
Well, that's a common problem, the whole shadow IT environment of the businesses going around IT and doing things very quickly in the cloud, because that's what the cloud's great at, is being agile and letting the business units launch resources very quickly without going through the guidelines and the architecture and the bottleneck that they feel is the IT department. The nice thing about the cloud is it is very agile and it is very flexible, so it's easy to retrofit a lot of those things into that environment. I think key is for an IT department to understand what their business is doing in the cloud, and knowing that these business units have gone rogue and have gone out there and procured assets or resources out there that may not be deployed in the most secure manner, in the most cost-effective manner, and may not have things like disaster recovery and high availability and backups considered in their architecture.
Right, and we don't want those business units to resent central IT for butting in. And rather, the central IT needs to show value to the business, saying, we can help you do even better with the cloud by taking advantage of what we can offer you, rather than, hey, that's against policy and I'm shutting you down, because the business unit's going to go to, the higher-ups, whatever that might be, and say, they're trying to shut us down, but this is making us money. Like, this is one of our core products that we launched in the cloud, and we're pulling in, $1 million a month. You can't shut us down, and IT is going to get rebuffed.
Right. So what I tell IT departments is make it easy for people to use services in the cloud. So just like they can go out and procure infrastructure services or platform services or database services in the cloud, provide that same service and that same response time, but do it in a way that's governed and secure. Build some guardrails for adoption for your business units so they can use these things very quickly in the cloud, but do it in a safe and secure way.
Okay, so give them enough latitude within the lines to do what they need to do, but still have those, like you said, guardrails there to keep them from straying too far into the murky depths.
Exactly.
So you and I have been working for clients that have what they'll call a cloud-first policy, which, in other words, the answer to the problem is always the public cloud, unless you can present a solid case against it. Does that policy make sense, and what might you suggest as an alternative to that policy?
Well, cloud is certainly the latest buzzword in the IT landscape.
Right.
But like everything that we know in IT, the cloud or any solution, there's no silver bullet that meets every requirement that's out there. The cloud is just one option that I think we have to provide flexibility and agility and solutions to business units, but it's not the only one. I think cloud first is okay in concept to say we want to look at the cloud, but it's not a cloud-only solution. There's a lot of things that don't necessarily fit in the cloud. Certainly dev test loads work well in the cloud. Things that have to scale up and down rapidly work well in the cloud. Things that don't run all the time. Things like elastic MapReduce Hadoop clusters that need to spin up and spin down. Genome research, things where they're running large jobs and then the infrastructure sits idle for a large period of time, work well in the cloud because you can start up those resources and shut them down. But there's other things that don't work well in the cloud. So production loads that are on 24/7 that have a sustained load might be better in the data center. Things that have high security requirements that might be better in the data center where they can be more tightly coupled or controlled.
Right, and then there's legacy applications that just can't fit in the cloud because they have some sort of on-prem hardware requirement. If you have something that runs on an AS400, that's probably not making it up there. And the other example that I hear is data locality. I either need to keep the data close to my workstations and my information workers, or I need to keep the data in a specific portion of the world because there's data sovereignty requirements around that. And I know the public cloud providers are getting better with that. They're building data centers in those countries so they can say, yes, your data will live in this country, but you can still use our service.
And some of the bigger ones like AWS and Azure, for instance, have agreements with, for instance, the European Union, where data can leave the European Union and stay within AWS or within Azure and still meet the requirements that the European Union have put on the data governance there.
Right. So making it easier to consume the public cloud, right? That's their business. How can we get you in there? But yeah, not everything fits. And that's why I think you see the hybrid cloud model being the most popular of the three, private, public, or hybrid. It's definitely has the highest rate of adoption.
Yeah, and I think a lot of that right now is because companies are still learning about the public cloud. They recognize that there's a lot of interdependencies with existing systems. So they're providing that hybrid cloud so they can start to migrate stuff to the cloud, not jump in 100% because they're not quite sure yet. That they want to assume that all that risk. So they're providing that connection between the public cloud and their on-prem environment, that hybrid cloud, so that they can move data freely back and forth. Another thing that doesn't work well in the public cloud is applications that are latency dependent. Manufacturing applications where they're controlling some sort of robotics may have some latency issues.
That round trip time to the public cloud and back could be the difference between whether an assembly line gets backed up because an error wasn't caught in time and has a 3-hour reset versus catching it in time and being able to just make adjustments on the fly.
That's a good the latency issue with the manufacturing applications is a good example of where, while it makes sense to have the management loads on premise, the data that's generated from those is a perfect use to go up into the cloud, where it can be consolidated from multiple manufacturing plants, and then large processing jobs can be run against it to identify anomalies, to monitor for quality, and things like that.
Right. So time-sensitive stuff is processed closer to where the action is. But then, like you said, there may be deeper things that are hidden in the sensor data, and being able to upload that to a service that could do that sort of big data processing could expose those things and maybe increase manufacturing efficiencies or identify potential anomalies that could require a recall or something like that, trying to prevent issues before they happen.
Right.
That's a great example of what the hybrid cloud really looks like. Right? In our journey, we've established a policy for how the public cloud is going to be used. We've charted a route to the public cloud with stages, and we have a goal in sight, but I know the trip can get a little bumpy on the way. What are some of the common pitfalls and boondoggles a company can encounter on their cloud journey?
I think one of the biggest things I see is that you need to have executive sponsorship of the cloud. There needs to be buy-in from the executive level that, yes, the cloud is a direction that we support. If you don't have that, then I think your chances of success in the cloud are very limited. Once you have that executive sponsorship, though, there's really three areas that really stand out in my mind. Lack of in-house expertise. So the cloud is new to a lot of people. So I spend a lot of my time on education, helping people understand what the cloud provides and how to effectively do things in the cloud, because it is a little bit different than what most people are used to.
Right, and I'd imagine, like you said, having executive sponsorship then can also get the internal people the training that they need to understand the new technologies, because expecting them to learn it just on the fly is unrealistic and is probably a recipe for disaster.
Exactly.
It makes a lot of sense to bring in a consulting group to at least get you started and provide that basic understanding, but at some point you're going to want your in-house people to take over. So having an executive who understands that and is willing to shell out the dollars to pay for the training, or at least pay for the downtime for the person to do the training, that's a pretty big deal.
Definitely. The next area where I find the journey gets a little bumpy is in the governance and the cost of the cloud. It's so easy to spin up resources in the cloud. It's so easy to do things that a lot of times businesses are doing them not very cost effectively, and they're doing things in not a good, secure way.
Right. It's a shift in fundamental thinking about IT and consumption of resources. It's a way that we're very comfortable thinking about in like a manufacturing capacity. You're very comfortable thinking about the cost per unit. of all the different parts that go into it and the cost of goods sold in your balance sheet, that all makes a lot of sense when you look at something that's like manufacturing or concrete, right? But when you're thinking about IT, you're like, no, that's my server. It sits on premise. I've already paid for it. It's a sunk cost. It's a asset that I'm depreciating. I don't have to think about my compute cycles and paying per processor and paying per amount of memory or disk I/O or any of that. When you shift that workload to the cloud, suddenly that becomes really important.
And very visible.
Right. I know that some people thought going to the cloud was going to be a cost savings. And they were like, oh man, we're going to get rid of this data center. We're going to get rid of all this equipment. We're not going to have to pay all that, upfront cap cost. Instead, we're just going to have this OpEx. But that OpEx number could be a lot larger than initially expected.
Exactly. If not maintained correctly, it can definitely grow. I mean, the cost to run equivalent infrastructure 100% of the time in the cloud is going to be more than what you're paying in your data center, because you're also paying for the electricity and the heating and the cooling and all that other stuff that is built into that service in the cloud. The key benefit to the cloud is the ability to not run those things when you don't need them. How much of our on-premise infrastructure sits idle from 6 p.m. at night to 8 a.m. the next morning?
Well, right. I mean, we kind of had that problem back pre-virtualization, where we had these big honking servers that were only ever using like 5%, 6% of their resources, even under like a decent amount of load. So we solved part of that problem by having virtualization, being able to better utilize our physical hardware. But there's still downtime, and that's fine when you're running your own data center. But like you said, when you're in the cloud, you don't want that server running when it's not being used, and it can pop up and down pretty quickly.
Exactly. So that's the beauty of the cloud, is the automation capability to be able to start things up, to shut things down, to not have to build for worst case scenario of load of, hey, in between November 25th and December 25th, I have to have 3 times the capacity I need the rest of the year. Well, let's just add capacity then, instead of building out an infrastructure that sits idle for 11 months of the year to sustain that 1 month of high load. So that's the beauty of the scalability of the cloud.
That's a great point, and I just want to hammer that home a little bit. When we're building stuff on premise, we have to think about worst case. So what happens if a disk fails? What happens if the server fails? What happens if the rack fails? What happens if the site fails? And in a true HA environment, I need all of those things to be able to fail, and my end user is still able to do their work effectively, which means I need a ton of additional capacity that may never be utilized. Cloud's a little different.
Yep. Spin those resources up on demand. There's lots of DR and HA architectures for the cloud that are a fraction of the cost of putting in a complete replica set of hardware.
So how do I get my head around my costs and start controlling them?
So in the cloud, it's a lot of that governance comes in play initially when you're designing what you're going to do, and coming up with some best practices on how to name your resources, how to tag those assets out there so that you can report on them and you can understand, how am I allocating these costs? These are things that most businesses don't do in their data centers today.
Right.
They don't know how to allocate the cost of a VM to the business unit that's using it.
Right, and that's been like the golden fleece or whatever. The potential goals of chargeback that I've always heard, IT leadership talking about, we want to implement chargeback and chargeback to the business users, chargeback to the departments, but it's so hard to make that a concrete cost that you can actually charge back to them and say, yes, I spun up 3 servers for you last month, so you now owe me this out of your budget. It's hard to push back because these are already resources that you were consuming anyway. It's not like you had to go out and buy a physical server for them, because you're probably doing all virtualization.
And there's so many components that go into that. It's not just the cost of the physical infrastructure. It's the power. It's the heating and cooling. It's the disaster recovery capabilities. It's the networking, the pipes to the internet. And it's the people resources, too, that all factor into that.
Right. But now if I have an accounting app and all those resources in the cloud are tagged as accounting, I can say, hey, accounting department, these are your resources, this is how much they cost in the last month, and this is what you owe me out of the budget. Like, that chargeback becomes realistic.
Yes.
Whereas in a private cloud scenario, it was almost always a great idea that no one could really successfully implement.
Exactly.
And I think there's a third pitfall that you mentioned.
Security is probably the one thing that everybody thinks about with the public cloud. Oh, I'm not going to put my stuff out where it's not secure and the public can get to it. In reality, once people understand where things live in the cloud, stuff in the cloud is generally more secure than it is in your data center. If you look at who has access to your data in your data center, generally your system admins have access to the data. How much of your data internally is encrypted? Probably very little of it. Your network admins probably also could get to that data. Who can walk into your data center and pull out a disk and walk out with it? Probably a lot of people. Do you have biometric scanning? Do you have some sort of tracking? Do you have cameras watching what's being done? What type of security do you have in your data center? The reality is most businesses never invested in that level of security. Look at the cloud vendors, though. They have all that level of security and more. They have complete separation of duties between the people that can actually touch the hardware and the people that can log into the systems to get access to the data. And if all your data in the cloud is encrypted, like we recommend, then the people that even have physical access to the disks can't do anything with the data because it's all encrypted, and they can't decrypt it.
Right, and they don't have access to the encryption keys to decrypt it because that's a separate responsibility and a separate part of the company. Yep. So you'd need collusion of a pretty vast scope to have that data exfiltrate through the cloud vendor. It's not to say that there aren't security risks with the public cloud, but from a physical security standpoint, you're going to be in much better shape generally moving it to the public cloud than your own data centers.
If it's well architected.
Right. I like to make the analogy of my data center is like storing my car in my garage. Is it safe? Yeah, it's pretty safe. Could someone just walk up and open the garage door and then drive off in my car? Yeah, they probably could. The public cloud is like storing my car in a high security parking garage. Yes, there's lots of other cars there, but someone can't just walk in and drive off with my car. Like,
right.
There are lots of additional security things there to prevent that from happening versus my, two-car garage at my house. I could lock down my two-car garage like Fort Knox, but it's pretty unlikely that I'm going to do so because it's cost prohibitive.
Right.
So, yeah, from a physical security standpoint, I think we're, pretty safe on the cloud. But the other side of that is their responsibility for security only goes up to a certain point, and then that line is demarcated in the sand. And once you go past that, it's now your responsibility to secure things properly.
So the key in the cloud, no matter what cloud vendor you use, the data still belongs to the company that's using those cloud services. It's your responsibility to secure that data in the cloud. So you have to make sure that it's encrypted, so it's secure at rest. You make sure when you're transmitting, you're using SSL transmission, HTTPS, to make sure that it's encrypted in transit. Ideally, those encryption keys, you can let the cloud vendor manage those for you, and it's somewhat automated. Again, they have things in place so that the people that have access to the encryption hardware cannot get to your encryption keys, so they have separation of duties there. Mm-hmm. But you can also encrypt the data with your own encryption keys, so that even the cloud vendor doesn't have access to the encryption keys. So if you're ever concerned about a breach of the cloud, maybe not even your equipment in the cloud, but somebody else's equipment in the cloud, where law enforcement came to them and said, we're subpoenaing your systems, we want all the data off of them. Well, even if they got the data that you had stored there and it was encrypted with your keys, they wouldn't be able to decrypt it.
Right. But it's not just a data encryption. There's also all the common things that you would have to do if you were running your own data center. So like you said, securing inbound and outbound traffic, making sure that you have some sort of firewall in place, that you're doing packet inspection, that you're following best practices when it comes to opening up ports and filtering traffic. Like, all the things that you would do in your own data center, you still need to do in the cloud.
Definitely. It's just a lot of times it's a different way to do things. And you don't have to do those in the cloud. There's nobody sitting out there and saying, you can't deploy this until these things are in place. It's up to you to make sure those are in place.
Right. And that's where a strong central IT and security team come in and go, hey, we want to help you adopt the cloud, and here are some best practices that we want you to follow. Those guardrails, again, to make sure you're staying within the boundaries set for you by central IT, but still being able to deliver your product.
Exactly.
Some of our clients look to adopt the cloud by simply lifting and shifting their existing workloads to an IaaS, or infrastructure as a service environment, built in Azure or AWS. Does that approach make sense to you? Or so what are some of the positives and negatives of doing that? And what would a good alternative be to lift and shift?
I think lift and shift is just one of the mechanisms to move things into the cloud. It makes sense if you're at a lifecycle event on the underlying hardware where you don't want to invest in purchasing new hardware to put into your data center, to lift that up and shift it over to a public cloud infrastructure as a service. But I don't think that's the long-term approach to making the best use of the cloud. There are other methods to move things in the cloud, and when we talk about migrating to the cloud, I reference the 5 R's. The 5 R's, as Gardner defines them, are rehost, which is basically a lift and shift. That's picking up your existing applications from an infrastructure as a service standpoint and moving them into the cloud. There's refactor, which is taking those existing applications, moving them to a platform as a service, so where you don't have to worry about the infrastructure systems, the underlying hardware anymore, and you're just running on a platform. Revise, which is slightly changing the application to make it a little bit more cloud-friendly and probably running in a platform-as-a-service environment. Rebuild or rewrite would be completely replacing an application with something that is more cloud-friendly, probably takes some time. Or replace, which would be replacing an in-house application with maybe a SaaS-based offering or an off-the-shelf offering that's cloud-friendly.
Okay, so let's walk through those 5 R's with some examples. The first one we already kind of talked about, lift and shift. I've got, this 3-tier application that exists on premise. I want to move it to the cloud, and I am going to stand up an application server and a web front end and a database server all running in IaaS, and it's going to be exactly the same. It's like a mirror copy, more or less. Easy to do because you're not doing anything new. You're just changing where it's set up, but probably not making the most efficient use of what the public cloud has to offer.
Right. In that scenario, we still have to manage all the underlying hardware just like we do in our data center.
Right.
So we didn't really gain any benefits of the cloud.
Aside from moving it up there, so if I'm trying to close down my data center.
Right.
But again, we talked about cost, and that's not the most cost-effective way probably of going about it. So the second one you mentioned.
Refactor. So refactor in that scenario would be, instead of just lifting up those applications and building them out in the cloud, it would be taking that web front end, for instance, and maybe in AWS, you'd deploy that with Elastic Beanstalk, platform as a service where AWS manages your underlying infrastructure. And then the database part of that could be sitting on RDS, the relational database service from AWS. So again, you don't have to maintain that underlying database service. So now you're gaining the economies of not having to worry about the underlying infrastructure using the platform that the cloud provides you.
Right, and if there's some middle-tier app server that needs to exist, that could remain as an IaaS instance that's being fed by the other components, but you've probably lowered your overall costs because you're now consuming RDS and Elastic Beanstalk instead of having, IaaS instances running.
Exactly.
So that's a good concrete example. So let's move to the next one, which is
Revise.
Revise.
So Revise, we might look at that infrastructure and maybe we can take, say, that middle tier application server. Maybe that's running on a VM today. What if we could build that same application with Docker? So with a slight modification of the code, we can deploy a Docker image of that and run that Docker image in the cloud.
Right, using like the Azure Container Service or the Elastic Container Service in AWS.
Right, so moving it to a platform as a service, again, where we don't have to manage that underlying physical infrastructure.
Right, but in this case, I'm actually having to rewrite some code to get it to work in that container versus being able to just plop it in the cloud.
Correct.
I know web applications tend to be more forgiving of the just put it in a PAS, and same thing with database applications, because behind the covers, RDS is really just whatever database type you need. Mm-hmm. But I could see application servers not benefiting from that. So this sort of revised strategy works really well.
Right. So it's not changing the application per se, but it's changing maybe how the application sits on the underlying infrastructure to Dockerize it. So it's not a complete rewrite of the application. It's just revising it to support that cloud infrastructure.
Okay. And then the next one is Refactor?
The next one was Rebuild.
Rebuild. Okay.
Or Rewrite.
Okay.
Gartner calls it Rebuild, but it's basically looking at your application, rewriting it from the ground up to be more cloud friendly.
Right.
So that probably provides you the most benefit of moving to the cloud, but it's also possibly the most time consuming to take an application and rewrite it to be cloud friendly.
Right, because a lot of the times what you're doing is you're trying to break that application into the smallest components.
Microservices.
And turn those into microservices so that if the bottleneck is component C, I can scale component C separately from all the other components of my application. And that's where I get the most benefit.
Right.
And not just in the cloud, but just in general, because you can do that on-premise as well. That's not special to the public cloud necessarily.
Correct.
Right. So my web application that I'm building with the database backend, maybe I'm just going to refactor that or rewrite it entirely to break it into smaller chunks that manage different things, especially that app server.
Right.
And then the last one.
Replace. Replace would be looking at what an application that you use in-house provides today. Maybe it's a legacy application. Maybe it's something you developed custom in-house. And looking at off-the-shelf solutions, either a SaaS, software as a service solution, that provides that functionality, or off-the-shelf solutions that you can run in the public cloud in a platform as a service scenario.
Right, and I think the perfect example of that, and something we do an awful lot, is moving people from Microsoft Exchange to Exchange Online.
Exactly.
It's actually a pretty smooth transition because you're going from Exchange to Exchange. So another example would be going from like Lotus Notes up to Exchange Online. I'm replacing my email system with a hosted email system, and moving Exchange to like an IaaS platform would make absolutely no sense. Can you do it? Yeah, you can do it. Will Microsoft support it? They actually will now. But to run Exchange in Azure or AWS requires such robust hardware that it would be prohibitively expensive. There's no reason to do it, basically. So that's where you go to like an Exchange Online or something along those lines.
So perfect example of replace.
Right. Another one, and this just got announced, so interesting where it's going to go. If you're running, say, Jabber on-premise for your IM, you can now use Amazon Chime to replace that, and that is a platform or SaaS.
Yep.
That's a SaaS offering from AWS that could replace something that you're running on-premise.
Right.
So those are all the R's, huh?
Yes, 5 of them.
That's a lot of pirate talk right there, which makes sense since we're on a ship. So we talked about a lot of different ways to get to the cloud. One of the things that doesn't move nicely is legacy applications and the hardware that backs them. I feel like they're an anchor dragging down my airship. If I'm set on moving to the cloud, how do I drop that ballast and start climbing?
Unfortunately, there's no easy answer to how do you address legacy applications.
Well, why not, Bert?
It gets back to the 5 R's. You really have to look at all of your applications in-house and figure out, of those 5 R's, which ones doesn't make sense to move into the cloud. Key there is having some sort of application inventory.
What?
An application inventory, something that most companies don't seem to have, but everybody recognizes they would love to have.
Right.
And there are some tools out there that we use when we go into companies to generate application inventories and allow us to understand some of the dependencies and start learning about the environment so that we can identify what things make sense to move into the cloud and what's the process that we would use to do that. Would it be rehost, refactor, revise, rebuild, or replace?
Right. And building that application catalog, is very useful for other things. Your support contracts, if you don't know what applications you're running, you don't know what support you need. DR, if you don't know what applications you're running, how do you know how to protect them and support them in the event of a disaster? And just general like help desk support, knowing the applications and knowing who to contact if something goes wrong, like having a designated application owner. There have been many times that I've gone to a client and said, hey, do you have an application list? And they just kind of look at me like, well, no, I know what apps I run. I'm like, do you? Do you? Because there's probably Tommy over there in accounting who's been running his own little app on his desktop for the last 4 years. And when it breaks, there's one guy in your IT department who knows how to fix it, and he hasn't told you about this application. So, yeah, doing that discovery is kind of big.
Exactly. And it's even more so for cloud services, because a lot of companies don't have any clue how many cloud services that they actually consume. And when I talk about cloud services, we're not just talking about things in AWS or things in Azure or Google Cloud. We're talking about things like Salesforce, Office 365, Google Drive, Dropbox. All these are cloud services, and there's thousands of them out there that companies are using, and IT departments have no clue that they're actually using those.
Right, because the barrier of entry for all of those solutions is effectively nothing. You need a credit card, and you can sign your company up for it and create a tenant in whatever the services is. It could be like a project management service that your one group over in Arkansas is using. You have no idea about it because they pay for it on their credit card, and no one's mentioned it. And when they run into issues, they just go through the help desk that's provided by the service.
Exactly. And if I'm the CSO at a company, that would be concerning to me, not knowing what cloud services people might be uploading my intellectual property to.
Right. So that project management service could have a lot of really important IP sitting in it that you have no idea about. Right. That needs to be under some sort of data governance.
Is it encrypted? How do I know it's out there? Who has access to it? What happens when somebody leaves the company and they have an account in this project management service? Does somebody actually shut that down when they leave? Right. All these things are key. One of the things that Anexinet does or can offer is the ability to do through what's called a cloud access security broker is monitor internet access from a company and identify all the cloud services that a company might be using and prioritize those based on a level of risk. When you sign a contract with a cloud provider, you putting that credit card up there and you're checking that box that says, I accept the terms and conditions. How many people actually read those terms and conditions? How many people don't know that the terms and conditions say, when you upload your data, we own it?
Right.
A lot of cases that's true.
That seems dangerous. That's the sort of thing that maybe a legal team might want to comb over a little bit before you start uploading all of your very sensitive data into, Joe's project management shack.
Exactly. But the fact that you can start up that account with just a credit card, you no longer need a purchase order from the finance department and somebody to sign off on it. You just put your credit card in, check that box, and you're up and running.
Right, and then you just expense it.
Yes.
Oh, that's fantastic. So the last thing I want to talk about a little bit is that a big advantage to the cloud is that everything is API driven, so it can be automated. And I know this is starting to trickle down into private cloud and stuff that runs on premise. But so how do you think that automation helps drive efficiencies and lower costs for the people adopting the cloud?
I think the automation capabilities that the cloud provides, and even some of the private cloud services that you can run in-house, OpenStack and things like that, the automation around that allows companies to scale their resources, just like VMware or virtualization did a decade ago, to allow us to scale the number of systems that we can manage with the same amount of resources.
Right.
So it allows us to do a few things with that scale. One of them being replication and security around the deployment of those things. So we define how things are deployed in a secure manner. We version that code, so infrastructure as code. It's now replicatable, and we can use that many, many times and deploy the same code, the same process and know that it's done secure every time it's done.
Right. In the same way that in VMware, you have a template VM that you use to clone all your Windows or Linux servers off of. That already has all the appropriate software and best practices stuff applied to it. Mm-hmm. So when I clone something off that template, it already meets my company's requirements. In the same way, when you have a document of some kind that can be a configuration document that can be used as a template to deploy to the cloud or any API-driven service, the requirements are codified in there, and it's going to be consistent every time you deploy it. You don't have to worry about the little tweaks that Tommy the admin made to the server to try to eke out a little extra performance. Like, that should be in the configuration document, not in Tommy's head.
Exactly. And all that gets versioned, so at any point in time, if you had a regulatory requirement maybe to reproduce an environment from 6 months earlier, you just go back to the template that was used that's in version control, and you could replicate that environment.
That sounds like magic. That doesn't even sound possible. Yeah, so I see a lot of app dev teams are doing a lot with continuous integration and either continuous deployment or automated deployment of some kind of their code, right? But that stuff still needs to run on infrastructure of some kind. I've seen a trend and some pushback from those app dev teams to the infrastructure team saying, hey, we can deploy our code in minutes to each environment, but it takes you 3 months to stand up a new environment, and that's unacceptable. How can you stand up that environment better? Or even worse, it takes you 3 months, and then we go to deploy our code, and you set it up wrong. Or it's not the same, or dev doesn't match staging, or something along those lines. How can we get it so that you're deploying your infrastructure in the same way that we're continually deploying our code? And this infrastructure as code thing is a perfect way to do that. I'm versioning my infrastructure. When I want to deploy to dev, I'm using the same template or configuration document that I'm using to deploy to staging, that I'm using to deploy production. So not only do I know that the code is going to be the same for the application, but the infrastructure that runs it is also going to be configured the same and consistently.
Exactly. It's reproducible.
Right, reproducible. Imagine that. It's just madness, right? And you mentioned a little bit about like the scale and how you can manage a lot more servers as one resource than you could before. And that also kind of lends itself to this, because if you're managing servers in the old style where you log into each server through SSH or RDP and you make changes and then you log into the next server and do the same thing, you can't scale.
Correct. So by using a configuration management system like a Chef or a Puppet or an Ansible, now you automate that. And your servers actually maintain themselves, essentially. So when you need to update the version of, say, OpenSSL on all your web servers, well, maybe you have 100 web servers out there that have the role web server. And when you go into the Puppet configuration and you say, for the role web server, I need to upgrade my OpenSSL version from version 1.1 to version 1.2, the next time that web server checks in with the Puppet master, that update will automatically be pushed down to that web server.
What, you mean I don't have to log in to all 100 web servers and run a command?
Never have to log into your web servers again. It's all done through your role configuration in your Puppet master.
That sounds, again, like magic.
It can be to seem like that to some people. I think as traditional infrastructure people recognize the benefits of the automation, they start to realize that now they don't have to spend all that time doing that operational task of logging into server 1, logging into server 2. Now they do it one place, and they sit back, watch everything get updated, obviously check to make sure it works, but now they get to go do more fun stuff.
Yeah, I mean, it just makes your job more interesting. So getting back to where we started at the beginning of this conversation, as an infrastructure person, your job isn't going away. It's becoming more interesting. And if you don't want your job to become more interesting, then maybe IT's not a good discipline for you to be in. Just putting that out there. If you like doing menial, repetitive tasks, I'm sure you could find another job that would be much more boring. But I think our goal is to make our jobs more fun and interesting, and this is certainly a way to do it.
Exactly. If you love to learn, looking at the cloud and being in IT in general, with all the changes that are going on, is a great place to be.
I agree. Well, Bert Zahniser, thank you so much for being a guest on AnexiPod. The last question I have for you, and I ask this of all guests, is what is your favorite 80s movie?
Favorite 80s movie? Yeah, I'd say Star Wars is probably the original 3.
You can't pick the original because that was 77, but you can do Empire or Jedi.
Okay, we'll do Empire or Jedi then. Probably Jedi is the one I like the best.
Wow.
Yeah.
Most people go Empire, but hey.
I actually like the scene where Luke gets on he goes to see Jabba the Hutt, and he's about ready to be pushed off of the ship.
Right, into the Sarlacc pit.
Right, and he winks at R2-D2. R2-D2 shoots out the lightsaber, and he takes everybody down.
It's a great scene.
Yeah.
All right. Well, thank you again. If people want to know more about you and what you do you have any social media or blogging that you do?
You can find me on LinkedIn. You can also find my blogs occasionally on the Anexinet blog site.
All right, great. Well, thank you again, Bert.
Thanks for having me.
And that was our interview with Bert Zahniser. If you enjoyed the AnexiPod and are looking for more content, why not check out our sister podcast, Buffer Overflow? On the show, I am joined by Anexinet colleagues to discuss what's new and interesting in the IT news sphere. Thanks to Catherine and Patty for helping me pull this together. Thanks to Lee Rosevere and Professor Click for providing the music for AnexiPod. Thanks to Anexinet for helping me produce this podcast. If you're looking for a company to help you with your digital, strategy, or technology needs, then I would recommend reaching out to Anexinet to see how they can help. And finally, thanks to you, dear listener, for tuning in. Without you, I would be a lunatic talking in a room to myself. If you'd like to know more about me and what I am up to, you can check me out on Twitter at Ned1313 or my website, nedinthecloud.com. Thanks for tuning in, and remember, IT moves pretty fast. If you don't stop to look around once in a while, you could miss it.